Hey there, this is a video for my 30SH students. We are in Chapter 6 and we are learning how to solve rational equations. This is lesson 6.4 in the chapter. This video follows a couple of videos that Mr. Lacko made. Some of you have probably already made these notes, in which case if you check the answer key and you got everything right, you really don't need to watch this video. But for people who would like a little bit of help with this stuff, then follow along and see if you can see where maybe you went wrong. To solve a rational equation, that means solve for the variable, you need to eliminate the variable. This is done by identifying the lowest common denominator, multiplying both sides by the lowest common denominator, simplifying, solving the resulting equation, check for non-permissible values, check your solutions by substitution in the original, that's an I, equation. Now, what the difference between what we've been doing up till now and this is when we were just adding, like say for example we were just adding these two things. When we, oops, I said we were adding. Just looking ahead to the first example, what if instead of an equals between them there was an add, and all I asked you to do was add them together? Well, remember when you're adding fractions, you can't change the value of the fractions. That's a no-no, right? If this was -2/7 plus 1/5, you would just say, oh, okay, I have to times top and bottom here by 5. I have to times top and bottom here by 7, because this principle of oneness allows you to multiply without changing its value, because timesing by 1 doesn't change the value of anything, and then you get your common denominator of 35. Well, equations have a different kind of vibe to them. You see, in an equation, here's a very simple equation. X plus 1 equals 2. Well, x must be 1. In an equation, you actually can do what I've been warning you about back here, that you can't change the value of the things you're working with. In this case, I can change their value, but I have to change it by the factor of, by a common factor to all three terms. If I multiply both sides of the equation by 2, I get 2x plus 2 equals 4. And notice that's the same equation. I know it looks very different, but it still has the same solution. And if two equations have the same solution, then mathematically they're the same equation, right? This equation I started with had an x equals 1. This equation here has an x equals 1. That makes these two equations equivalent. That means that they're the same equation. So you can do that. You can multiply both sides of an equation by a number. We're going to multiply both sides of this equation by the LCD because it's going to allow us to eliminate the variable. So I won't usually show this step when I'm working, but since this is the first example, we'll do this the formal way. So I'm timesing this side of the equation by the lowest common denominator, and I'm timesing this side of the equation by the lowest common denominator. Okay, whoops. And then from there, that factor cancels that one, that factor cancels that one. Now distribute. -2 times x plus 5 is -2x minus 10. And then this is x minus 1. Now I'm going to move everything that's got an x in it to one side, leaving me -3x. I'm going to move everything that's a constant to the other side. So I'm adding 10 to both sides, so that makes this a 9. So x is going to equal -3. Now, let's check our oh, sorry, I'm off the page. There we go. So x is equal to -3. Now, let's check for non-permissible values. Remember, you got to go back to the original equation for that. Well, x can't be, non-permissible values, x cannot be 1 or -5. Well, my x turned out to be neither of those things, which is good news. So that means this could be the right answer, but I'm still going to do a verification. -2 over, replace the x with -3, equals 1 over, replace the x with -3. And are those two things the same fraction? I think they are, because that's -2 over -4, which is a half, and this is 1 over 2, which is a half. Yep, we have verified that that's the right solution. Okay, so that's an easy one. They get harder. Let's check out this one. Okay, this one, we need a lowest common denominator of 2x. So we're going to multiply each term, and there's 3 different terms here. Terms are, of course, things separated by add, subtract. So there's 3 separate terms here. They all need to be multiplied by 2x. So multiplying this by 2x is just going to make 5. Multiplying this by 2x is going to make 4. And multiplying this by 2x is going to make 6x. Make sure that it makes sense to you why that works. When you multiply these terms by 2x, it just cancels the 2x's on the denominator. So that's 1 is equal to 6x. So x is equal to 1/6. Check for NPVs. And the NPV on this one is obviously x cannot equal 0. Well, that's not a 0, so it should be a solution. And let's put in a verify. So let's verify our solution. 5 over 2 times a sixth minus 4 over 2 times 1/6 is equal to 3. Is this a true statement? That's 5 over 1/3 minus 4 over 1/3 is equal to 3. These kind of already have a common denominator, so I'm just going to use 1/3 as my denominator. 5 minus 4 is 1 over 1/3. And yeah, 1/3 goes into 1 3 times. So yep, that is the correct answer. All right, number 2. I'm going to multiply both sides of the equation by x plus 2, which cancels it on the left. And on the right, it leaves me with 5/7 times x plus 2. And I might as well multiply both sides of the equation by 7 while I'm at it. Cancels it on the right. And then I'm going to distribute minus 5x from both sides. I'm kind of out of room, so I'll go up here. So x is equal to 5. And again, what are my NPVs? Well, x cannot equal -2. That's not a -2, so that's good news. And then we'll do a verify. So my check, sometimes I call them checks instead of verifies. That's going to be 5 over 5 plus 2 is equal to 5/7. And yes, that is definitely 5/7 is 5/7. Checked. Okay. How about, this one's very similar to both number 1 and 2 kind of together. Why don't you pause the video, give it a try if you haven't already. If you're just checking in on this video and checking your work, you've probably tried it already. But if you haven't tried it yet, pause the video and try it for yourself, and then I'll catch up to you. How'd it go? So I multiply everything here, all 3 of these terms by 2x, leaving me x minus 1 plus 2 equals 4x. I'm going to move this x to the other side and collect those 2 like terms. And so x is once again equal to 1/3. Okay, we can check that that's true. First of all, I guess maybe we should do non-permissible values. Only one of them. X can't be 0. That's not a 0, so we're in good shape there. And my check is that that is 1/3 minus 1 over 2 times 1/3 plus 2 over 2 times 1/3 equals 2. I have a common denominator here, so I basically have a 1/3 minus 1, which is -2/3 plus 2 over 2/3 has to equal 2. That's 6/3 minus 2/3 is 4/3, so I have 4/3, and when you divide by a fraction, you times by its reciprocal, and those cancel, and I am left with 2. So that is the right answer. Okay, so that's example 2. Example 2, 1, 2, and 3. There's a few more here, a couple more. Let's try this one. So let's see. This one here, I'm going to times by the LCD, which is x minus 2 times x plus 4. When I multiply the left by those 2 things, the x minus 2 cancels, so I have 1 times x plus 4. And when I multiply this side by those 2 things, the x plus 4 cancels, and I have 5 times x minus 2. This is the kind of question some people would call what we just did a cross multiply, because it's like this one moved up and multiplied there, and this one moved up and multiplied there. Keep in mind that only makes sense when you have a ratio equals a ratio. Notice if you tried to cross multiply on one like this one, you'd be a little bit lost because it's not a ratio equals a ratio. So that's x plus 4 is equal to 5x minus 10. I'll move the x's to the right and the constants to the left. So 14 is equal to 4x. So x is equal to 7 halves, because that's 14 divided by 4. My non-permissible values are x can't be 2 and -4. And my verify will be 1 over 7 halves minus 2 equals 5 over 7 halves plus 4. 2 is really 4 halves, so that's 7 halves minus 4 halves, so that's 1 over 3 halves. And 7 halves plus 4, that's 8 halves, so that's 5 over 15 halves. And in fraction land, when you're dividing, you times by a reciprocal, so 1 times the reciprocal of 3 halves is 2/3. And 5 times the reciprocal of 2/15 is 5 times 2 over 15. And notice both sides are 2/3. Okay, this guy. All right, so my lowest common denominator here is x minus 1 times x plus 3. So when I multiply both of these things on the left side, it'll cancel the x minus 1, and I have x plus 1 times x plus 3. When I multiply this side by both of those things, the x plus 3's cancel, and I have x minus 1 times x minus 1. And that is going to be, I'm going to get a quadratic out of this one, x squared plus 4x plus 3. And on this one, I'm going to get x squared minus 2x plus 1. All right, I'm going to minus x squared from both sides, which really effectively cancels them. Then I'm going to add 2x to both sides, and I'm going to minus 3 from both sides. So I'm getting 6x is negative 2, so x is negative 2 over 6, which is negative 1/3. I'm going to do, first of all, my NPV check. Is that a non-permissible value? No, my non-permissible values are x can't be 1 or negative 3. And then I'm going to do my verify. All right, let's verify this. So that's negative 1/3 plus 1 over negative 1/3 minus 1 has to equal negative 1/3 minus 1 over negative 1/3 plus 3. Okay, so that's 2/3 over negative 4/3. And this side is negative 4/3 over, let's see, 3 is 9/3. So 9/3 minus 1/3 is 8/3. All right, when you're in fraction land, divides are multiplied by the reciprocal. The 3's cancel, and I have negative 1/2 on this side. And over here, I'm going to have negative 4/3 times 3 over 8. The 3's cancel, and that's negative 4/8. And those two things are the same. So we got it. All right. Moving along. Part 2. Solving rational equations. And notice it's the same steps. Don't have to go through those again. But notice what's different about this one is now I have a ratio on both sides, rational on both sides, and an extra constant. So now my LCD for this one is x minus 1. So I times this term by x minus 1, giving me a 2. I times this term by x minus 1. And I times this term by x minus 1, giving me a 4. So that's going to be 2 plus 3x minus 3 is equal to 4. I'm going to move all the constants to the other side. So 3x is equal to 2 minus 3 is negative 1. Add the 1 to both sides, so 3x equals 5. X is equal to 5/3. The non-permissible value for this was x cannot equal 1. Well, that's not a 1, so we're good there. But I'm going to do a verify. So let's do the verify on this one. 2, so my check. Sometimes the questions will ask you for a verify, and sometimes they won't. 2 over 5/3 minus 1 plus 3 has to equal 4 over 5/3 minus 1. Okay, 5/3 minus 1, 1 is 3/3, so that's 2/3, so that's 2 divided by 2/3 plus 3 has to equal 4 divided by 2/3. And let's see, 2 divided by 2/3 is actually 2 times 3 over 2. And the 2's cancel, so that's 3 plus 3. So this side's 6. And 4 divided by 2/3 is like saying 4 times 3 divided by 2, which is also 6. So there we go. That one works. All right. Next, what do we do with this guy? All right, let's think about this one. For this one, the lowest common denominator is 2 times x minus 7. So I'm multiplying all three of these terms by both of those factors. So that is going to leave this term, the x minus 7s will cancel, and this will be 2 times 2x minus 9, plus, They don't give you a whole lot of room here on this page. Plus this middle one here, this middle term, the x, the 2 cancels, and this will be x times x minus 7. And on the other side of the equation, the x minus 7's cancel, and I have 5 times 2. We're ready to simplify. So we're going to distribute all the brackets. 4x minus 18 plus x squared minus 7x is equal to 10. All right. Now, when I was solving for a linear, I always keep the x's on one side, the constants on the other. When you're solving for a quadratic, and we'll do a lot more of this later in the year, but when we're solving for a quadratic, we actually move everything to one side and collect like terms, and you leave 0 on the other side. You'll see why in a second. So that's going to be x squared. I have 4x's minus 7x's, which is minus 3x's. Then I have negative 18, but then I'm going to minus 10 more, so that's negative 28. And now we use our factoring skills. Quick, what 2 numbers times to make negative 28 but add to make negative 3? That's negative 7 and positive 4. So that means that x is equal to 7 or x is equal to negative 4. Okay, you know what we haven't done yet is we haven't done an NPV check. And our non-permissible values are x cannot equal 7, and that's it. And whoop, wait a minute. For the first time in this lesson, actually we got the non-permissible value as one of our solutions. So that solution doesn't work. It is extraneous. This is the only solution that should work. Let's do a quick check to see if it works. All right, I'm kind of out of room, so I'm going to write really small here. Some of you guys are masters of writing small, so I'm going to channel your energy for this one here. So this is 2 times negative 4, which is negative 8, minus 9, over negative 4 minus 7, which is negative 11, plus negative 4 over 2, which is negative 2, and that has to equal 5 over negative 4 minus 7, which is 5 over negative 11. So, or negative 5 over 11. Doesn't matter where you put the fraction, it's negative. All right, so this is negative 17 over negative 11 plus negative 2 has to equal negative 5 over 11. All right, those negatives cancel each other, so this is 17 over 11 minus, because that's plus and minus, and 2 is actually 22 over 11. As you can see, yes, that'll be negative 5/11. That is a correct statement. That is the right answer. All right. Okay, now number 3. Let's try this guy out. Okay. This time I'm going to have to break up my factoring skills to figure out what my LCD is. So the first thing I'm going to do is I'm going to factor 2 over what 2 numbers times to make negative 6 and add to make 1. That's going to be plus 3 and minus 2. Okay, so now I'm going to multiply everything here, all 3 of these terms, by the LCD. And the LCD in this case is x plus 3 times x minus 2. So when I multiply this thing by both of those, well, they both get canceled and I get a 2. This, excuse me, the x minus 2 is going to cancel, and I'm going to get 1 times x plus 3. And here the x plus 3 is going to cancel, and I'm going to get 3 times x minus 2. All right. So this thing's linear, so that's 2 plus x plus 3 is equal to 3x minus 6. I'll move the x's to the right, so that's 2x on this side. 2 plus 3 is 5. 5 plus negative, or 5 minus negative 6, so that's really 5 plus 6 is 11, and x then is equal to 11 halves. Okay, so let's check our MPVs. Well, the MPVs here, you have to go to factored form, could be negative 3 and 2. Okay, my answer is neither of those things, so it passes the first check test. Now let's do a verify on that. Okay, so verify. So 2 over 11 halves squared, that's 121 fourths. This is a bit ugly. Plus 11 halves minus 6 plus 1 over 11 halves minus 2 has to equal 3 over 11 halves plus 3. Yoicks, that's some fractions. Okay, well, the common denominator here is 4, so that's 2 over 121 plus 44. I better write this out. can't do this mentally. Minus, and if I change this 6 over 1 into fourths, that would be 24 all over 4. Meanwhile, over on this guy, I have 1 over 11 over 2 minus 4 over 2. And over on this guy, I have 3, and that's 11 over 2 plus 6 over 2. I'm going to run out of room here, aren't I? Yes, I am. But oh well. Let's just keep going. So this is 2 over, and let's see, 121 plus 44 is 165. But 165 minus 24 is, let's see, 165 minus 24, that would be 141, I want to say. Somebody should double check my mental math here. Let's see, let's just make quite sure that I did that right. 121 plus 44 is 165, and I am minusing, right? Yeah. Minusing 24, 141. Yep, I agree with that. It is 141 over 4. Plus, this is going to be 1 over 11 minus 4 is 7 over 2, so 1 over 7 over 2. And that's then going to be 3 over, and 11 over 2 plus 6 over 2 is 17 over 2. Hoi, this is looking gross. All right, I'm going to see if I can finish this off over here. Kind of out of room there. All right, so that is going to be, you divide in fractions by timesing the reciprocals. That's going to be 8 over 141 plus 2 over 7 equals 6 over 17. Oh my goodness. Do those two things actually make the same fraction? Well, I honestly don't know. I'm actually really wondering if I got lost somewhere in this. Let's see. 11 halves. Maybe I don't have the right number. Maybe I've goofed this up. Oh well, let's keep going. In for a penny, in for a pound, as they say. So let's see. The common denominator here would be, let's see, 141. Is there a 7 in there? No, there isn't. So I think my common denominator is I'm going to have to times this guy by 7. So that's going to be 56 plus, I'm going to have to times this guy by 141. 241 is 282 all over whatever the heck 7 times 141 is. And all of that has to equal 6/17. Really now. Okay. Well, if you're wondering why I'm not bothering to multiply that out, it's because I have to prove this equals this side, so I have to actually kind of simplify this and somehow. So I'm hoping it factors. So this is going to be, let's see, 2 plus 6 is an 8. 5 plus 8 is a 13. So a 338 over 7 times 141 is equal to 6 over 17. Now, if I counted by 141s, I wouldn't hit 338. I really don't know what kind of numbers go into 141. 4, 5, 6. It has a 3 in it. 8 and 6 is 14. There's no 8. There's no 3 in that though. Does 7 go into this number? 7 goes into 28, and then 4. I think I must have made a mistake. If this is getting this bad and it still doesn't look like I've got the right number, I think I better go back and see if I've made a mistake. So let's see. Where did we get lost? Did we factor properly? Let's start from the beginning. Plus 3 minus 2. Agreed. My common denominator is plus 3 minus 2, so when I times this, it's just a 2. When I times this, it's a plus 3. And when I times this, it's a 3 minus 2. And that's 3x minus 6. And then I move the 2 to the other side, it's 2x. 2 plus 3 is 5. 5 plus 6 is 11. I stand by my answer. I am going to start this verify all over again. So here we go. Trying to put this into there. That is 2 over. 2 over. 11 over 2, which is again 100, because I'm squaring it, 121 over 4, plus 11 over 2 minus 6, plus 1 over 11 over 2 minus 2 equals 3, and then that's 11 over 2 plus 3. All right. So the common denominator here is 4, so that's 2 times 121 plus 22, and I think that might have been my mistake. Yes, there's my mistake right there. That's where this thing went off the rails. Haha, found it. So that's going to be minus 24 all over 4 plus 1 over, that's 11 over 2 minus 4 over 2 equals 3. 11 over 2 plus 6 over 2. This is going to work. I can kind of see it working now. 2 over 121 plus, how about this? 22 minus 24 is negative 2, right? So negative 2, take 2 away from this. That's 119 over 4. That's still kind of an ugly number, but it's not as bad as it was a minute ago. Plus, and over here I have 11 minus 4 is 7 over 2. And over here I have 3, and this is 17 over 2. Okay, so now 117 does have a 7 in it. So I'm actually going to, again, times this by the reciprocal, giving me, oh, my hand froze. I'm frozen. There we go. 8 over 119 plus 2 over 7 is equal to 3 over 17. Oh, sorry, 6 over 17. That's better. And let's see. What can I do with this? There is a 7 in here, right? And I think this is actually 7 times 17. I think it is. Yep, 7 times 17 would be 70 plus 49, which is 119. So I'm going to times this guy by 17 over 17. And that's going to be 8 over 119 plus 2 17s is 34 over 119 is equal to 6 over 17. 8 plus 34 is 42 over 119 equals 6 over 17. Both of these things have a 7 in them. And there it is. Phew! That was fraction-o-rama. I don't think on a test I would ever spend that kind of time trying to verify a fraction answer. But it is right. If you have a very, very good command of your calculator and you really wanted to make sure and you were allowed a calculator that you had the right answer for a question like this, I'd probably just run it through the calculator. I would probably go 2 over, and where's my over button? Oh, hang on, you gotta hit the over button first. 2 over, and then put down there. Let's see, 11 over 2, which I might change to a decimal, so that'd be 5.5. 5.5 squared plus 5.5 minus 6, move it on over, plus another big ugly fraction-y thing, 1 over 5.5 minus 2, and what does that equal? It equals 6/17, and I already know that side 6/17 because remember, we just did fraction nightmare. Ah! So we know that's what it is. Okay. So, next, we got 3 more examples, and some of these get kind of tough. Okay, this is fun. I like these. So this is an LCD. Maybe I should factor that first. That one's factored. That one's factored. This one is factored now. So my LCD is x plus 1, x minus 1. My NPV, now that I'm in factored form, is x cannot equal plus or minus 1 because that would make those two things 0. So I'm timesing both sides of the equation by this denominator. So the numerator here is going to be x minus 1. This numerator is going to be x plus 1. And this is going to be 2. So that's 2x equals 2. X equals 2 divided by 2, which is 1. Whoops. Wait a minute. 2 divided by 2 is 1. Problem. Non-permissible value says, therefore, no solution possible. In other words, there is no number in the whole universe that can make this equation true if you plug it in for x, because the one number that balanced the two things is not a permissible value. Wah, wah. Number 5. Let's see. I got a factoring I got to do first. 1 over x plus x minus 1 over x times x plus 2 equals negative x over x plus 2. All right, my LCD is x times x plus 2. My NPV is x can't be 0 or negative 2. And I am ready to times everything by those two things. So this side's going to get an x plus 2. This side's going to get nothing. And this side's going to get negative x times another x. Aha. So I have x plus x, which is 2x. I have 2 minus 1, which is plus 1, and that is equal to negative x squared. I'm going to move that to the other side. Remember, when you're solving a quadratic, everything moves to one side. X squared plus 2x plus 1 is equal to 0. That factors to x plus 1 squared is equal to 0. I'm going to square root both sides, and x is going to equal negative 1. I won't bother doing a check on that. I don't want to end up in another fraction nightmare like I did on number 3, but it looks pretty good. I think we've got that one. And last, and certainly not least, number 6. This is the last one. Yay, it's the last one. Okay, so let's find what we get when we factor this. This is 9 over x times x plus 6 equals 2 minus x all over 2 times x plus 6. Okay, so my LCD is a 2 times an x plus 6. And my NPVs are x can't be 0 or negative 6. All right, I'm going to sharpen the pencil for this guy. So what is this term missing from the common denominator? I'm going to multiply everything, so it's going to cancel the 2 and the x, and the part that's missing is the x plus 6, so it's going to be 1 times x plus 6 minus 9 times 2, because the x and the x plus 6 will cancel when I multiply this term by the common denominator, equals 2 minus x times, okay, so the 2's cancel, the x plus 6 cancels, but there's another x that I'm going to multiply here. And there we have it. Let's simplify all that. X plus 6 minus 18 is equal to 2x minus x squared. I'm going to move everything to the side. I get positive x squared. I get x minus 2x. And I get 6 minus 18, which is minus 12. What two numbers times to make negative 12 and add to make negative 1? Negative 4 and plus 3. So x is equal to 4 and x is equal to negative 3. And I'm pretty sure if you plug both numbers in, they will both work. I'll leave that up to you to try. Neither of them are non-permissible values, so if you do a verify, they should both work. Cool. That is, barring that one little fraction mistake I made, a pretty good look at how to do the stuff in 6.4. There is 2 pages after this that we're going to skip for right now because they get to these kind of equations, but there's a couple that 2 of the 3 examples have these kind of equations that don't factor, and we don't learn how to deal with stuff like that until after 2 units from now. So we'll come back to that page 2 units from now. Till then, practice these and good luck with them. Have fun. I love these. These are fun. These are like Sudoku for me. Talk to you later.